Uh, so here we go, scale and scale factor. So this goes into section 8.3 in your book. So you kind of know where you're at. Okay. So some definition here. Scale diagram. Okay. A drawing in which measurements. Oh. One second. It's one of those things. My mind is going. Okay. Drawing which measurements are proportionally reduced or enlarged by a constant factor from the original / actual. So most of the time scales, right, maps are very famous for that, right? There's the actual landscape and then your map, right, reduces it. But it's not just reduced in one dimension, it's reduced in every dimension by the same amount, okay? And then you have your scale, the ratio of a measurement somebody help, just push that, of a measurement of a scale diagram to the corresponding measurement. On the original / actual object. Scale factor. Let's do the credits thing. Okay. Scale factor and the scale factor is denoted by a letter K, right? I don't know why K, but hey, that's I'm not going to argue with them. Okay. Is similar to I'm going to do this after. Similar to a scale, but is expressed as a fraction, decimal, or percent. it has no units. I'll put a star here, comma, since they cancel out. Since they cancel out. Very important, okay? So how are scales and scale factors related? Okay, a scale follows this pattern always, okay? So it has the diagram, right, on the left, and the actual on the right. So the number on the left represents what has been used on the diagram and how much that represents in the real world, okay? Another way of looking at it is also when you're making copies, okay, you would rather want to use new and original. So let's say you're making a pot and you want to make a copy of that flower pot, you want to make a bigger one, then it's easier to think of it as the new object than the original you started off with, okay? When you're looking at maps, pictures, anything like that, you rather use diagram and actual, okay? But these line up, okay? When I say actual, original, they kind of mean the same thing, okay? Scale factor, on the other hand, would be like this. You write it like this, k is equal to, as a line, right? Because it's going to be a fraction most of the time. Diagram goes up here. Actual goes down in the denominator. Or when you're making copies of something, new and original. Right? Sometimes you make a prototype of something, right? You make a small version of what you want to build. It's like, okay, I'm happy with it, so that's the original. I'm going to make a bigger version of it. That'll be your new. Okay, so this is, I will just make sure you put no units here again. No units, convert as necessary. Okay, convert as needed. That's the thing about scale factors. I'm going to box this whole thing in. Okay. Maybe I should do this because it has thrown students off. So I'll just say like this, use when making copies of original. Okay. The students are like, well, Mr. Erickson, which one of these two should I use? My answer will be, it depends on the situation, right? If you're looking through a microscope, you're looking at a cell, I would use diagram actual, right? The actual cell and what you're looking through is a diagram, really. Okay, so here we go. I think I'm going to give an example. So let's say you're given 1 centimeter represents 50 kilometers right? If you see that, you know that that's a scale, right? A scale is written as a ratio always, right? And if nothing is given, no context, you're going to go diagram actual, right? So this is diagram, and this is actual. Okay? No problem. Scale can have different units, right? But if you wanted to write this as a scale factor, right, to convert this into a scale factor, the first number always goes on top, right? And the second number always goes in the denominator. Okay? But what's wrong with this? You cannot have units. Okay? This would be wrong to put it that way. So we need to convert different units. I'm going to put that down. Okay? So I'm going to convert. Different units convert. So I need to have everything in centimeters in this case. You're just going to have to trust me on this one. I picked a really bad example. This wasn't supposed to be kilometers. Can we change that to meters? Am I going to mess up your notes if I do that? Yeah. My bad. I'm just going to use meters. Otherwise, it's going to be really, really, really small. I'm not going to give you something like that. So anyways, we need to convert the meters to centimeters, right? So let's quickly take this out and just do that, right? 50 meters, right? 1 meter has 100 centimeters. Nope. Mr. Dirksen, you're making a lot of mistakes for a math teacher. Yep. Okay. I'm doing this wrong, so let's do this again. 1 meter has 100 centimeters. Can you agree with that? Yep. There we go. So it's 50 times 100. Now we're talking. Okay, and that goes back in there. We need to make sure they're both in centimeters. And now you can do this. Watch, it's so satisfying, right? You can get rid of the units because that's what you ultimately want. So K is really 1 over 5,000. That's what you want to do. Sometimes they happen to be the same. No problem. Cancel the units, move on. But the units in this case were not the same. We had to do a little bit of converting, bring it back into the scale factor, and then state it like this. Let's state that as a decimal, right? So we go 1 divided by 5,000. It's very small. That's not what I wanted. I have to change the settings on that calculator. There it is. 0 point, it was giving me scientific notation there. Right? That's what it is as a decimal, 0.0002. And as a percentage, you just keep that on your screen, you multiply that by 100. So it's 0.02%. All three of them are acceptable. Most of the time I keep it as a fraction. If I can keep it as a fraction, I leave it. But the occasional question might ask you for decimal percent. Okay. All right, let's do some, we're going to do a little bit of sketching because you need to know how to do that. Back side. And this will contradict the textbook a little bit. Just follow my example, working with scale diagrams. Okay, so let's say example, the dimensions of a room are 12 meters by 8.6 meters. 12 meters by 8.6. Draw a scale diagram using 1 centimeter is equal to 2.2 meters. And here are the steps that I want you to follow. When you're given something like that, just follow these steps. Okay, convert actual dimensions using scale. Step 2, draw object using conversions in 1. 3, label diagram with actual dimensions. We use actual dimensions when we actually label that thing. If you have a ruler today, great. If not, you're just going to have to wing it. So watch how I do this. Basically, if you look at actual dimensions of the room, right, we have the length is 12 meters and the width is 8.6 meters. Okay. Now we're going to have to figure out what are our dimensions for our diagram that we're about to sketch. Let me zoom in a little bit here. Is that better? Because I technically don't go past the red line. Okay, so for every single one of these, you use that scale. Okay, so 1 centimeter has 2.2 meters. And do you recall when which one of these is actual, which one is diagram? The top is diagram. I'm off the charts there, right there. And this is actual. Just to remember that as you're working. Okay, so the top, like when I look at the length here, the 12 meters will go here. 2 reasons: meters match with meters, and this is the actual measurement of the room, so that should go down here. Okay, so we'll call this length of the diagram. So you cross multiply and divide. So you go 12 times 1, divided by 2.2, and you get 5.45. And I'm going to cut this here. Repeat the same step. I'm using the same scale because remember, everything is affected by the same constant. But in this case, I'm going to use the 8.6 here. And this is the width, right? So you cross multiply and divide. 8.6 times 1, 2.2, divided by 2.2. And that will give me, for the sake of time, I'm just going to tell you what the answer is, 3.91 centimeters. Right, so I'm going to use these to actually draw my diagram. Okay, so that's what you're going to use to actually sketch it. So it's 5.45 in length, 3.91 width, so I'm going to make sure I have enough room. So I'm going to go 1, 2, 3, almost 4, not quite. Okay, I'm going to use the top line to make my 545, which is almost 5.5. Right, so I want 1, 2, 3, 4, 5, and 45. And again, I'm not going to sit there and make sure you're right by the nearest, millimeter. As long as it looks okay to me, that's fine. So you use this to sketch, right? But what are you going to label it with? You're actually going to label it like this: 12 meters and 8.6 meters. Because you have to think of it this way: if you're giving this blueprint to a carpenter, he's going to know, okay, this is how the actual dimensions are. It was just drawn, right, with a certain scale to get it to that point. Okay. I'm going to tell you to do page 3 in the booklet. And this deals with section 8.3, okay?